Hello, hello, and welcome to a little video about the introduction to exponential functions. Here is the standard form of our exponential functions. We have a times b to the x. A is our starting point. AKA our y-intercept, AKA the initial amount. B is our constant ratio, or just ratio, AKA the pattern. Every exponential function has an asymptote. Now in the parental function, so in the base function, and we'll talk about how they change, but right now we have an asymptote of y equals 0 in most functions. And again, you'll see why. We'll just keep it at that. An asymptote is a dashed line that the curve approaches but never touches or crosses. When we graph them on paper or in calculators, you will see it look like the graph gets flatter, but it's just getting infinitely closer to a specific line that it can't cross. And what that means is it is impossible to get that specific answer regardless of what you plug into the equation. All right. In the next couple problems, we're going to identify the constant ratio. And just as a reminder, because it has been a while, on tables and graphs, we find the constant ratio, or I think it's supposed to be of tables, on tables. We find the constant ratio, or I guess we can. Tables? Yes. We get the constant ratio by doing term 2 divided by term 1, which on tables can be y2 and y1, but when we're looking at graphs, we would have to do the full-on slope formula with y's over x's. But for now, when we have the constant x's, we could just do the division of the y's. Alright, let's take a look at sequence A. Sequence A, these pictures and the equation are all sequence A, but we're going to practice finding it. I guess the graph we can't really practice finding it, but at least I can point it out to you on the equation. We'll practice finding the constant ratio on graphs in a different part. In sequence A, let's find the constant ratio by doing y2 divided by y1. So we'll do -6 divided by -2, and our constant ratio, the b term, is 3. It means the pattern here is multiplying by 3. And, you know, that works. -2 times 3 is -6 times 3 is -18. Now on this graph in particular, it would be hard to find the constant ratio because I don't actually have a grid here. But if that were to happen on a calculator, if this was your image, I would just pull up the table anyways. On equations, all we have to do is look for our b. There it is. b equals 3. So for sequence B, let's find the constant ratio first on the table by doing term 2, 90, minus, divided by, I almost said minus, oh my goodness, term 1, 45. 90 divided by 45 is 2. Let's check if that works. 45 times 2 is 90, and 90 times 2 is 180. Now, if we were able to zoom in and have a more accurate graph on the graph, we could do the same. But for the equation, all we have to do is look at that number, b equals 2. Now let's do some actual graphing. We are going to graph these various exponential functions, and we're going to do that by plugging in an x into our function, and then we'll graph the points we get. So here we have 4 to the power of x. when I say that x is negative 2, what I want you to do is do 4 to the power of negative 2. You can put that into your calculator, and you should get 1/16. We're going to do the same thing for negative 1 and get 1/4. We're going to do the same thing for 0. We get 1. We're going to do the same thing for 1. We get 4. And then 2, we get 16. How would we use this table to graph? Well, it gives us 5 points. Negative 2, 1/16. Negative 1, 1/4. 0, 1. 1, 4. 2, 16. Now, am I really expecting you to graph negative 2, 1/16? No, that's kind of crazy. But we could at the very least start with 0, 1. Here it is. 1, 4, and then 2, 16. I think I could guess where 1/4 is for negative 1, but that's as much as I'm going to do. All right, let's connect with a curve, and we flatten it out. Oh, that's ugly, but pretend it's being flattened out beautifully. There's our graph. Let's do number 2. Just like number 1, we're going to plug in that x. And I'm going to do that with every single x that I get. All right. I'm assuming you have a calculator and are doing the same. Okay. We got negative 2. Whoops. Oh, thank goodness. I thought that would stop my recording. We got, oh, I'm scaring myself, huh? Stop it. Just scroll gently, nicely. Love me. Okay. Got negative 2, 9. Negative 2, 9. Negative 1, 3. Negative 1, 3. 0, 1. 1, 1/3. I feel like I can guesstimate that. But 2, 1/9, I'm not even going to try. I'm going to connect it and flatten it out. Meow. Okay. Number 3, let's do the same. Ooh, it has a 2 in front. Doesn't really make a difference in the way we do it. We're just going to make sure to type that in when we do that in our calculator. Okay. Hopefully you have the time to put this into your calculator. Pause the video if you don't. Negative 2, 2/9. I'm not going to try graphing that, but I do feel confident I can guesstimate negative 1 2/3. That would be like there. 0, 2. 1, 6. And 2, 18. Whoa. I'm going to try that curve again. That was ugly. Okay, that's as good as it's getting. And I think number 4 is the last one we graph. Alright, let's do it. Pause the video if you want to do this in your calculator on your own. Whoops, that was on accident. Okay. Hopefully, when you're unpausing this, you've already done all your calculations in your calculator. Make sure to practice this. Don't just copy it down if you're watching the video and you miss the notes. You should really practice this on your calculator. Muscle memory is real. If you feel comfortable with the buttons, you will succeed on the test. The first point is negative 212. I can graph that easy. Then I got negative 1, 6. That's fine too. Got 0, 3. 1, 3/2. 3/2 is 1.5. I feel comfortable doing that. 2 3/4. I feel like I can guesstimate that. Alright, here's my curve. Now looking back at these four, oh thank goodness, stop it, just let me zoom out, just love me. Alright, look at these 4 graphs. Do you see how some of them are going downhill and some of them are going uphill? Hopefully you notice that the ones that are going uphill have whole numbers inside the parentheses, or whole numbers risen to the power of x. The ones that look like they're going downhill have fractions, or numbers smaller than 1. I need to move this out of the way. Would that work? I guess so. That's fine. Let's look at number 5. You know it messed number 4 up a little bit? That's okay. What we're going to do in number 5 is we're going to match the exponential equations to their graphs. I think the easiest way to go about this is to look at their starting points. The starting points are the numbers in front of all the functions, in front of the number being raised to the power of x, and they are the y-intercepts. So for letter A, I have a 1 in front of 2/3. In letter B, I have 2. In letter C, I have 4. And letter D, that is a negative 1. All right, let's match. This has a y-intercept of 2. All right, that's just one option, letter B. I'm just going to write B under here. This has a y-intercept of negative 1. That's letter D. This has a y-intercept of positive 1. And this has a y-intercept of positive 4. For number 6, we are going to write every exponential function for the given table. I just had a brain fart. I'm sorry I'm having such a brain farty kind of video today. Remember, here we have the starting point and then the ratio. And, whoops. Okay. In letter A, the first thing I want to identify is the starting point. There it is. That's my starting point. Now let's find the ratio. Remember, in order to find the ratio, we do the second term, y2, divided by y1. So we would do 2 divided by 2/3. Put that in your calculator, and we get 3. All we gotta do now is put it all together. But first, let me color code. You know how it is. y1, y2. Okay. F of x equals 2 times 3 to the power of x. Let's do the same for letter B. First, let's identify the starting point, the y-intercept. There it is. Perfect. Now let's label y1, y2, and find the ratio. y2 is 15, so we're going to do 15 divided by y1, which is 75. 15 divided by 75 is 1/5. Our function is f of x equals 3 times 1/5 to the power of x. Let's try that one more time for letter C. Here's my my y-intercept. And now let's identify y1, y2. y2 is 28, and y1 in this case is also 4, just like the starting point. So for our ratio, we'll do 28 divided by 4, which is 7. Our function is f of x equals 4 times 7 to the power of x. We can do the same thing from graphs. Check it out. First, we need our starting point. There it is. That's 0, 4. Easy peasy. Now, however, we do need to find the rate. Or the ratio, sorry. We have 0, 4. All we need is one other point to find it. This is 1, 12. All right. Well, we still have y1, y2. Our ratio is going to be 12 divided by 4. So it's 3. And now we have everything we need to write our function. F of x equals 4 times 3 to the power of x. For letter B, it doesn't matter which 2 points we use. I just drew 3, and we'll see what each class picks. But for now, I'm going to use this starting point, which is 0, 3. Perfect, we need that. And this point here is 1, 1. I'm going to call this y1. I'm going to call this y2. To find our common ratio, our constant ratio, we're going to do y2 divided by y1. Our constant ratio is 1/3. That's all we need in order to write our function. F of x equals 3 times 1/3 to the power of x. All right, let's do it twice more, and I think we're good to go. I didn't really give you many options for C and D, just 2 points each. First, let's identify a starting point, 0, 2. And then our second point is 1, 10. y2, y1. Whoa. Let's find our common ratio. by doing y2 divided by y1. So when we do 10 divided by 2, we get 5. And we've got everything we need to write our function. F of x equals 2 times 5 to the power of x. Last one. Let's label my starting point. This looks like 0, 3. And then we've got this point right here, which is negative 1, 12. y1, y2. Oops, I didn't mean to do blue. y2 and y1. All right. Our ratio is going to be 3 divided by 12. Whoops. 3 divided by 12 is 1/4. So we've got f of x equals 3 times 1/4 to the power of x. Oh, I know that was a lot. If you have any questions, please feel free to ask me or whoever else is helping you out in math. Otherwise, have a wonderful rest of whatever day it is for you. Bye!